So we are going to continue talking about education today and focus mainly on K-12 education. But before I do that, I just wanted to recap the punchline from the last lecture. And as you can see with this poll, those of you who haven't filled it out yet, feel free to punch in your response. Want to get to this question of whether we should prioritize meritocracy or equality of opportunity. So just to summarize where we were, kind of the bottom line lesson from the end of the last lecture, in the context of higher education, what we found basically is if we try to knock down all the barriers that low-income students face in applying to elite colleges and paying to attend an elite college and so forth, there's only so much we can do in terms of increasing the representation of low-income students at places like Harvard at elite colleges. Because if you look at students' qualifications, like SAT scores at the point of applying to college, students from low-income families have already fallen quite far behind students from higher income families. And so the only real way to increase the socioeconomic diversity of the student body at places like Harvard in a really appreciable way is to have a class-based affirmative action policy, to actually kind of lean in and take an active stance that you're going to change the requirements at some level to get in for students from lower income backgrounds. And so that creates the possibility that there could be a real trade-off between the principle of meritocracy, which I think many people find very appealing, that the people who are most qualified to get something, like get into college, for example, should be the ones who get in. It creates potential tension between that principle and an interest in increasing social mobility and trying to give kids from low-income families access to the types of institutions that might serve as sort of a launching pad to reaching higher levels of the income distribution or other good outcomes that you might care about. And so the way I ended the last lecture was by pointing out that it's basically a value judgment. What should universities be doing in terms of which of these two principles you ought to be prioritizing? Now, to be clear, it's not completely obvious that they're strictly in tension with each other. There might be ways you could identify more very talented low-income kids who would be, just based on pure merit, above the bar for the very best colleges. And so it's possible you can do more on that dimension to kind of achieve both of these at the same time. But at some level, eventually there could be a trade-off between these two things. And so I think it's a very challenging and important and interesting question, which of these two principles people would prioritize. And so what I've asked you to do here, in the spirit of economists tend not to like to make the value judgments themselves, but let people judge what they think objectives should be, just kind of see what the class thinks. And you can see, this is actually what I was sort of expecting. It's pretty divided. You can very reasonably have either view, I think, right? I mean, you can make a strong argument for meritocracy, that it's not Harvard's role to try to fix the problems that have emerged from differences in neighborhoods, K-12 schools, other things, by the time kids are 17 or 18 years old. Or you could take the view that college is maybe the great equalizer, and that's where you have a chance to really combat some of these disparities, and places like Harvard should be trying to take an active stance in addressing those issues. I think you can make a principled argument either way. And ultimately, people have to make some sort of decision on this in order to have a way to move forward. And so the role I see evidence playing here is in identifying the situations where it ultimately just boils down to a value judgment, and you can assess how far you can get with one approach versus the other, versus identifying cases like the University of Michigan HALE program that we talked about, the HALE scholarship program, which really has the feel of we're getting both of these things at the same time. That's kind of a win-win. There are these highly qualified students out there who are not applying for whatever reason. Let's get them in the pipeline. That's going to both increase social mobility and achieve our goals of meritocracy. So I think the way I think about it is push as far as you can on that approach, because why would you not want to? And then think in a principled way about the trade-offs that you face. There's basically, the way economists would think about it is there's a price you're going to pay in terms of meritocracy in order to increase social mobility. How big is that price? Are you willing to tolerate that price? What are your goals as an institution? So any questions on this set of issues before I move on? Yeah. objective. Yeah, absolutely. Yeah.
Because it's basically a way of doing affirmative action. Meritocracy is a way of doing affirmative action for whatever qualifications we decide.
Yep, yep. So that's a very reasonable point, right? And I distilled it here to actually a very narrow measure, just your SAT scores, to make it totally quantitative. And I think no one would argue your SAT score is a pure measure of merit by any means. So I think you're absolutely right that with broader definitions of merit, and in particular subjective definitions of merit, it's not clear that there's a hard trade-off between these two things, and you might be able to go in different directions and so forth. One way that you might be able to put a little bit of structure on that empirically, which is along the lines of work we're doing, I briefly mentioned in the last lecture, is try to think about it from an outcome-based perspective. So think about the set of students who go to Harvard. Suppose the university's objective is to admit and enroll students who go on to do great things in terms of becoming leaders in various spheres and so forth, right? So you could imagine using data of the type we've been talking about in this class to actually look at what types of qualifications at the point of admission predict later success. So a very crude way to measure that would be earnings, but you could do more sophisticated things like scientific contributions based on patents, or did you start a business that was a big job creator, or did you become a high-ranking government official or an important artist, or you could try to, in principle at least, measure lots of different outcomes and then ask what qualifications at the point of application best predict those outcomes that you care about. Could be something about SAT scores, it could be more subjective measures, it could be a variety of things. That, in my view, would allow you to get a little bit of a better handle on what you mean by merit, perhaps, and then understand what these trade-offs actually look like. That's one path to trying to put some structure, I think, on what you're saying. It's not, you might still say there are other subjective things you care about in defining merit, not strictly based on this outcome-based perspective, but it's richer, at least, than what I've been showing you here. So that's one direction we're trying to develop. Yeah. Yeah.
How sort of racial composition of Harvard and places like it will change under class-based
Yeah. Yeah. So it's pretty clear that the racial composition of the class would change significantly if you only had class-based affirmative action, because, as we'll talk about in some subsequent lectures, race plays a very important role, even conditional on class, in kids' outcomes and qualifications and things like that. So you should definitely not think of race as being interchangeable with class. Obviously, they're correlated, and minorities tend to have lower income, so the two things are related, but they're definitely not the same. Yeah. Can you say the same? What do I think would happen to the fraction of them, or? Right, yeah, exactly. Like now we have, I think it's like 10% black, 10% Hispanics. Yeah. If you had a pure class-based affirmative action policy, it would almost surely be less. Yeah, if you don't have direct race-based affirmative action. Yeah, that's the sense in which I meant they're not substitutes for each other. You're going to end up admitting more low-income kids, obviously, if you have class-based affirmative action, but they're going to be more low-income white kids typically. There are a number of more middle-class kids from minority backgrounds, racial and ethnic backgrounds, who are now admitted at a higher rate. And so obviously this is a very important issue that's currently being resolved in the court system about how, whether we should have racial affirmative action and how that should play out and so forth. My perspective is that the class-based affirmative action issues we're talking about here are they're related, but they are independent of race-based affirmative action. This stuff ends up coming up actually in the lawsuits on race-based affirmative action as well, but my own perspective is it's a bit tangential to what that debate is about. Obviously there are a similar set of issues at play, but it's a separate phenomenon. Say it again, I can't quite hear you. I mean, perhaps. I think it, again, depends upon people's social views, right? So there are reasons you might want race-based affirmative action that are different from why you might want class-based affirmative action. I can see a scenario where race-based affirmative action ends up not being something that's sustained, and then there's a shift towards class-based affirmative action. But I can also see a scenario where people, as you can see here, I mean, I think this poll is perfectly reflective of that. People's views are split on these sorts of things, right? I mean, I think you can make arguments on both sides of this. And so I don't feel well positioned to make a prediction on exactly how that would play out. Anybody else? Okay, so what we're now going to do is kind of step back in the education pipeline and talk about K through 12 education. And I think the discussion we just had is actually a good setup for why we should care so much about K through 12 education, because in some ways it allows us to avoid the tension that you could feel in that last poll, where if you wait until kids are 18 years old, you've got to make some really tough decisions about, how do you deal with different principles that you care about. In principle, if you were to try to tackle the problem much earlier, like when kids were born, and try to improve environments at that point, you potentially face less of a harsh trade-off, and maybe you can have more of an impact, okay? And so, with that motivation, not surprisingly, most countries spend a tremendous amount of money trying to think about how to, investing in education at the elementary level. And so the US in particular spends nearly $1 trillion per year on K through 12 education. Unlike many other countries, as you know, it's not a very centralized system in the US, right? So there's substantial variation in the way the money is spent and in the amount of funding across schools in the United States. And that's in particular because public schools in the US, as you know, are funded by local property taxes. And so that leads to very sharp differences in funding across areas where more affluent neighborhoods tend to have better funded public schools than less affluent neighborhoods. Now, that does not have to be the case, of course. You could, in principle, have a national tax base for local schools, and other countries have more nationalized school systems, but that is the feature of the US, and as we'll see, that creates a lot of variation. Moreover, as we'll talk about in the next lecture, in addition to the public school system, there's a growing presence, not just of private schools, which have always been there to some extent, but an increasingly large presence of charter schools that kind of try to break out of the traditional mold and the regulations of the public school system. And so there's a lot of active discussion in the policy debate about the K through 12 system at the moment, just like there is about higher ed, about, for instance, should we be supporting the expansion of charter schools, or how should we be trying to hire teachers or evaluate teachers, or how should we be dealing with issues of class size? So lots of, I think, very important and interesting questions. And at a broad level, all of these questions, they're trying to get at the issue of how can we maximize the effectiveness of the K through 12 education system to produce the best outcomes for students, right? Of course, that's like the overarching objective of all this. Traditionally, the way these issues were studied, coming more out of a straight education school education literature, was sort of qualitative work in schools or small-scale quantitative work studying specific schools. What I'll talk about here in the spirit of this class is the more recent, past 5 or 10 years, big data approach to evaluating the impacts of schools. And so I'm going to talk about results from a series of different studies, which are listed here. They're on your syllabus if you want to look in more detail at what I'm going to be covering here. Okay, so the primary source of data that people use to study the K through 12 education system is information on standardized test scores obtained directly from school districts. So rather than focusing necessarily on later outcomes like earnings, which is what we've spent a lot of time thinking about, most people, when they're working on, say, the effects of kindergarten education or third-grade education, they tend to look at test scores at the end of the year. As you all know, there are now standardized tests administered virtually all states to all students. And so that gives you, a quantitative outcome that's recorded systematically in existing administrative databases for virtually all students. So why would you focus on test scores rather than something that you might think is more meaningful down the road, like earnings or college attendance, things like that, it's because you see test scores much more quickly than you do long-term outcomes, right? So if you're thinking about an intervention, you tried to change something in your school last year, it's going to take a long time to figure out the impact of that on how students are doing as adults. But if you think, test scores are a good proxy for those later outcomes, you'll be able to see that just in a few months or just in a year, okay? And so that very simple fact has made test scores kind of the standard thing that people have tended to gravitate to. Now, a common concern, both among academics, but especially among the public, I think, with this approach, is just to ask, maybe you can use test scores, fine, you can measure test scores well, but are they actually a good measure of learning? Are they actually a good measure of what we care about in the long run? And so in particular, do improvements in test scores, if I have a teacher who's really good at raising kids' test scores, is that they're just better at taking tests? So like maybe a teacher is really good at teaching to the test and that makes you really good at getting a higher test score? Or is it actually about the acquisition of skills that have value later in life? So are you actually learning something when you score higher on a standardized test that's going to pay off in terms of the outcomes we ultimately care about, upward mobility, college attendance, et cetera? So the first thing I want to do before diving in and showing you a bunch of results on what types of things impact test scores is just to validate the test score measure. Like, does it actually seem like these things have predictive power for later outcomes? And so people have done this in a bunch of ways. I'm going to take data from a study we did, which I'm going to talk about in more detail in a little bit, where we have data on 12,000 kids who were in various kindergarten classrooms in Tennessee in 1985. So what's good about that data is you have test score data from a sufficiently historical period so that you can look at later outcomes like earnings 25 years later. These kids are now old enough such that you see those outcomes. So what we're going to do, similar to some of the other studies that I've talked about, is link the school district data and test score data to the tax records that we've used for other work. And we're basically going to ask whether kindergarten test score performance predicts later outcomes. Now, often I find when I'm describing this work, people ask, what are you possibly testing kindergartners on that could, have any predictive content? Like, what are these tests? So the best way, I think, to answer that question is to do an example. Here's an example of a kindergarten test that these students were actually given. Here's how it works. So I'll say a word to you. Listen for the ending sound. You circle the picture that starts with the same sound, okay? So if the word is cup, hopefully all of you here know that the answer is pencil and not duck. And so the question we ask as researchers is, how does the kid who unfortunately said duck instead of pencil, how are they doing 25 years later? And so here's the answer to that question. So here's your kindergarten test score percentile on the x-axis. And here's your earnings on the y-axis. And you can see that there's quite a strong relationship between those two things. And so let me say a couple of things about this chart before you get too excited about how predictive the test scores are. So first of all, just looking at the range, so notice that average incomes go from 10,000 to 25,000. That's a pretty big, in terms of multiples, 2.5-fold difference in income. Relatively low numbers, though. So that's because we're looking at a pretty disadvantaged population in Tennessee. These are relatively high poverty schools in the state of Tennessee. And you'll see in a second why we're focusing on this set of schools to study a set of issues we'll talk about in a second. So let's walk through a few different properties of this graph. Okay, so the first thing is the way this chart is constructed is it's what we call a binned scatter plot. So the simple thing that you might think about doing with these data is just do a scatter plot of kids' earnings in adulthood versus test scores. So remember, there are 12,000 kids here, so that would give you a plot with 12,000 dots. When you have a scatter plot with that many points, it's often very hard to see anything because it's just like a big blur of lots of points, right? So what we're doing here instead is telling you basically how average incomes vary with test scores, by binning the data. And so in particular, what we're doing is dividing the x-axis, test scores, into 20 equal-sized bins. Okay, so 20 bins, so there's 5% of the data in each of those bins. And we're showing you the average level of earnings versus the average level of test scores in each of those bins, okay? So that's the idea of a binned scatter plot, very widely used now with these large data sets to kind of understand what the shape of the average relationships look like. So to give you one specific example, students scoring between the 45th and 50th percentile, what you see in this chart is that they earn about $17,000 on average, okay? But important to emphasize there is that that is the number on average. That's obviously not the number for every kid who was between the 45th and 50th percentile. So in particular, if you were to look at the underlying data in that bin, you would see that there are lots of kids who do better than $17,000, and there are lots of kids who earn less than $17,000. That's just the mean, right? And so more generally, in all of these bins, we're gonna see a lot of variance around those averages, okay? So the reason I emphasize that is because while this relationship looks really striking, and it is in fact true that kindergarten test scores are on average a really good predictor of your earnings later on. If you were at the bottom of your class, you are gonna be earning 2.5 times less on average than kids at the top of the class. That does not mean that if I tell you your kindergarten test score for any given kid, I can predict with perfect accuracy how you're gonna be doing. So if you construct this statistic called the R squared, or basically the amount of explained variation in the outcome variable, we see that the test scores explain only 5% of the variation in earnings. So how do you put these two things together? You know, basically what you learn from this chart is that kindergarten test scores are highly predictive of earnings, which I think is the initial reaction a lot of people in the room had, that is a strong fact. But they don't determine your fate. It's not like if you got a low kindergarten test score, like that's it, you're never gonna have high earnings. There are lots of kids who have low kindergarten test scores and do pretty well, and there are lots of kids who have high kindergarten test scores and don't do as well in terms of earnings, right? So there's variance around that line. Okay, that said, you know, I think the idea that the test scores have no content in terms of telling you something about later outcomes is just wrong. I mean, there's clearly information in test score data. There's some predictive information. And so from at least a researcher's standpoint, it seems reasonable to be paying attention to how different types of interventions might affect these test scores. So I've been emphasizing earnings here. I just want to show you that it's not just about earnings. That's often the measure economists gravitate to first. But you know, lots of other things. So look at college attendance rates. So college attendance rates, if you were at the bottom of your kindergarten class, less than 20%. Top of your kindergarten class, even in this relatively disadvantaged population, over 80%, right? So again, substantial predictive power. Yeah.
Can you account for like test scores directly influencing these factors? For example, like if kids are separated into advanced and less advanced accelerated groups early on, that could like that persist.
Yep. Yep. It's a good question. Yeah. So you know, there are a couple different mechanisms that could be driving this relationship. So the one you're describing is kind of a causal mechanism where the test score you got might itself directly influence what ends up happening. So a very simple example like the one you gave is just a tracking system where if your test score is above some threshold, you get into like the gifted class or the advanced class or whatever, and then that gives you a better set of resources, which then ends up affecting your outcomes. So that could be part of what's going on. I think in principle, there's not that much tracking, especially at early ages. So I don't think it's literally that, but it could be some version of that, right? But then a totally different class of mechanisms is that this is just a correlation, right? So the kids who have high kindergarten test scores, they also are coming, you know, from more perhaps better families, better neighborhoods. They have more advantages in various ways. And it has perhaps nothing to do at all with the causal effect of the test score itself. It's just reflecting the fact that if you come from a better background, you have better outcomes in the long run. The test score is just like kind of a proxy in the middle. The way I look at it for our purposes here is I don't care which of those mechanisms it is. I just want to show you that test scores have some content in terms of predicting these later outcomes in order to justify the use of the test score as an outcome. So that's why I don't spend time trying to go into what the mechanism is for for the link here. But you're right, like it would be interesting to understand that for other purposes. Other questions? Okay, so predicts college attendance well. It even predicts things, that are quite different, like the probability you're married is fairly strongly related to your kindergarten test scores, okay? So there's a bunch of different outcomes you can look at that seem to be decently predicted by these early outcomes. Okay, so what I think you learn from that is that test score data can provide a quite powerful data source to compare performance across schools and subgroups. And as you'll see, it's very versatile. You can use it for lots of different things. So one simple problem you face, though, before you start to use these test score data to, say, look across school districts in America, is that, as many of you might be familiar with, these standardized tests that you take, they're not national tests, typically. They're state-specific tests or sometimes even local tests. And so the problem that creates is that they're not all on the same scale. So, suppose kids in Michigan take one test, kids in Ohio take a different test. Now you're trying to compare school districts across Michigan and Ohio. You basically have the numbers on two different scales. So how are you going to figure that out? There's some nice recent work that illustrates how you can overcome challenges like this by a leading education researcher and sociologist at Stanford, Sean Reardon, who solves this problem and creates a standardized measure of test score performance for all schools in America that's being increasingly widely adopted. So what he does here is use information on 215 million test scores for students from 11,000 school districts across the US from 2009 to 13 in grades 3 to 8. So like a really comprehensive set of data that the Department of Education has amassed on test scores across the United States. And so what he does in this study, the core methodological contribution, is to figure out how you put all those different test scores on a single national scale. And he does that in three, I think, intuitive steps. First, he ranks each school district's average scores within the statewide distribution. So let's say you'd have all your school districts in the state of Michigan. They all take the same test, right? So they're all kind of in the same units. So you can rank them from the very best to the very worst within a given grade, year, and subject. Okay. Then second, he uses data from a national test that's administered to a sample of students by the Department of Education every year to convert the state-specific rankings to a national scale. So the Department of Education, just to assess progress in the United States and education in the US, there's a random, relatively small sample of students who take a national standardized test that's on the same scale for everybody in the country. Okay, and so that kind of gives you can think of it as like a exchange rate between different states because everything is being put on the same scale in that test. And so how do you intuitively use that national scaling to adjust the state-specific test data? So suppose, for instance, California students score 5 percentiles below the national average on the national test. Okay, so that tells you California students on average on the same scale are kind of 5 percentile points behind. So then what he's going to do is go back to the now district-specific data. In the national sample, it's not big enough that you can have measures of test scores for every single district. So now he goes back to the district-specific data, the 215 million test score database he started with. And he says, suppose you've got a California school that's 10 percentiles below the California average. And we know California on average relative to the nation is 5 percentile points below the national mean. That tells you intuitively that this district is 15 percentile points below the national mean because it's 10 percentiles below the California average and California itself is 5 percentiles below, right? So you can see how you can use that national test to do this sort of benchmarking. And then finally, to put everything in kind of intuitive units rather than having it in percentiles or standard deviation units, they convert everything into grade level equivalents. So are you reading at a 5th grade level, 4th grade level, 3rd grade level, and so forth, to give you an intuitive sense of how far behind or ahead students are, okay? So that's the statistical exercise kind of distilled There are more details there, but that's basically what they're doing. And so then you can construct a plot like this, which shows you how test scores vary now on this national scale that you've created across all school districts in the United States. And so you see lots of variation from places like Detroit with relatively poor outcomes to places like Cambridge or Ann Arbor or Palo Alto, where you see very good test score outcomes for kids growing up there. Again, coming back to the earlier question, this is not necessarily about the causal effect of the schools on test scores. It could be about the backgrounds of the kids growing up in these different places. And a big part of what's driving this, as we'll see in a second, is just the socioeconomic status of the students, that you have more low-income kids in the districts on the left and more high-income kids in the districts on the right, okay? So you can then put that on a map to get a sense of what this variation looks like. And just to give you a sense of the scale here, so the purple colors, these are kids who are 2.5 or more grades below where they ought to be, you know, given the national average. So if you're a 5th grader, it's like you're reading at, you know, a 2nd grade or 3rd grade level on average for all kids in that district. So that is dramatically behind. And then the green areas, you know, are 2.5 grades above. You'll notice that broadly this map has properties that look a little bit like the maps of upward mobility that we've looked at. So it's a related set of outcomes, as I was just showing you earlier in this lecture. It's not identical, but you know, you get some feel for the Northeast has particularly good outcomes, parts of the West Coast, much of the Great Plains, et cetera. You zoom in and you can look at all of this data online on a website they've put together. You see very local variation, as we've seen in other contexts. So if you look around Detroit, for example, in Michigan, you see variation from dark purple colors to dark green colors with districts that are just adjacent to each other. Okay, as we've seen in other contexts, there's tremendous local variation in these test score outcomes. So next, what we're going to do with these data is ask how test scores vary across socioeconomic groups to get a better sense of what is driving this variation. So in particular, what they do in this study is define an index. They don't really have straight measures of income. So they define an index of socioeconomic status using census data on things like poverty rates, so measures of income, fraction of college graduates, single parent rates, and so on. So basically a bunch of things that are correlated with socioeconomic status. They average those all together to create an index of places that are basically more affluent, you know, they have more college graduates, lower poverty rates, things like that, and places that are less affluent. And so what you can then do is plot that achievement measure that we've now constructed for every district that I was showing you on the map before. That's on the vertical axis, how many grades ahead or behind you are in your district, versus this measure of socioeconomic affluence or advantage. So the places on the right side of this graph are very high income places, and the places on the left side of the graph are very low income places. And each dot represents a different school district, and then the size of the circle corresponds to the size of the school district in terms of the number of students. And so what you can see here is, as you might expect intuitively, there's a pretty strong upward sloping relationship. That is, a lot of the variation in average achievement levels across school districts in the US is explained by socioeconomic status. However, there's quite a bit of variation, even conditional on socioeconomic status. So one example of that is if you pull out all the Massachusetts school districts and all the California school districts, you see a pretty striking pattern, which is even at the same level of socioeconomic status, the same kind of average neighborhood incomes, kids in Massachusetts schools are, and this is all public school data, are you know, something like 1 grade level or 1.5 grade levels ahead kids in California. So it really seems, you know, at least suggests that there's something quite different about the environment in California, about the school system in California that's producing very different outcomes, even conditional on socioeconomic status relative to Massachusetts. And you can obviously look at that for a variety of different cuts of the data, not just these two states that I'm focusing on here. Now, moreover, you can then cut the data separately. You can look at it separately, cutting on the student's own parents' income. So this is, again, using this free and reduced price lunch measure, where the poor students in the yellow here, those are students who are eligible for free and reduced price lunch, and the red is for students who are not eligible for free and reduced price lunch. And the point of this breakdown, so now we're showing you the averages separately for those two groups of students in each of the school districts, right? So we're cutting each school district into those two groups. And I think what's interesting about this breakdown is that you may have had the intuition that if you're in a sufficiently well-resourced school, so you're in like the Palo Alto school district, or one of the affluent, like Newton, an affluent suburb of Boston, which would be on the far right here, you might have thought that the few lower income students who attend those schools, maybe they'd be doing quite well because they're in a really good environment. But in fact, what you can see is the gradient in the yellow dots, the slope is not that steep. So as you move towards a district that looks more affluent, that has better resources, low-income kids don't actually have that much better outcomes in terms of test scores. The high-income kids, in contrast, you see a bit more of a slope there. And so what ends up happening is that the gap in achievement between low and high-income kids is actually larger in the best school districts in America than it is in the lower income, less resourced school districts in America, contrary to what you might have hoped, right? You might have thought, if the school district has enough resources, everybody's going to benefit, we're going to close some of these achievement gaps. No, they're actually exacerbated. And why are they exacerbated? Because the higher income kids benefit a lot from being in these more affluent places, and the lower income kids only benefit a little bit. And so that, I think, again, shows you that the path to fixing some of these problems, it's not as simple. Part of it is about differences in resources across these places, but there are important differences even across students within well-resourced places, okay? So the question then that emerges from those kinds of comparisons, you saw pretty significant differences across school districts in outcomes, even conditional on socioeconomic status, is how can we improve performance in those schools, right? How can you pull up some of those dots that we were seeing in that chart? So one simple thing that you might think of from an economic point of view, usually when you have a problem like this, the first thing that you think of is let's spend more money on addressing that issue. And I just want to start by saying that clearly could be helpful. If you have no resources, obviously there's not much that you can do. But it's not obvious that simply spending more money is going to be a solution, a panacea in and of itself. And so that's illustrated by this chart here, which shows you some international comparisons that I think are informative. So this is average test scores on the PISA International Standardized Test. Many of you might have read in the news, the US often doesn't do very well in terms of average test scores in comparison to other countries. So you can see the US is towards the bottom there. But the point I want to make here is if you plot average test scores versus average spending in primary education, you don't see a tremendously strong relationship here, right? So this is not definitive. It doesn't by itself tell you that spending more money is not going to do anything. But it at least suggests that the core reason the US has poorer performance is not because we spend dramatically less money on education than other places. In fact, you see lots of countries like Finland, for example, which is often held up as a shining example in this context. Finland is a place that actually spends less per pupil than the United States and has dramatically better outcomes on the PISA test. And so that's just to say, I think you need to think about this in a more nuanced way than just thinking about dollars of expenditure on the school system. Dollars could matter, but you also want to think about how that money is going to be spent. And that's what I'm going to focus most of the substantive discussion on in this lecture. Okay, so if you're trying to improve schools, you've got a certain amount of money, you're trying to spend it as efficiently as possible. How do you go about doing that? So I think it's, before we talk about specifics, like trying to reduce the size of classes or improve the quality of teachers or whatever it might be, it's useful to first think about two very different kind of conceptual policy paradigms, two different approaches you might take. The first you can think of as a government-based approach. So you've got public schools, let's figure out how to improve those public schools by doing specific things to them, by reducing class size, increasing teacher quality, et cetera. A totally different approach is to say, I'm not going to bother as the policymaker, as the government, to try to actually figure out what things I need to do to improve the existing system. I'm instead going to, as we do in many other spheres of the economy, just appeal to private market forces, right? So if you think about it in lots of different contexts, like I'm trying to invent a better smartphone, the government is not going to try to figure out how to improve a smartphone by itself. We don't leave that problem to the public sector. We just create incentives in the private sector such that you're highly rewarded if you develop a better smartphone, or we figure out how to set up the market so that you can buy certain parts of the spectrum, so that you can transmit signals, et cetera, right? So the government kind of defines the rules of the game, but then lets the private sector solve the problem of how you improve things. And so you can ask, similarly in the context of education, why is the government in the business of providing education? Maybe the government funds education, but why not leave it to the private sector to figure out the best ways to provide that education, in the same way that the private sector seems to be pretty good at figuring out the best way to discover new drugs, or the best way to improve technology, or provide products in other contexts. And so that second paradigm, the market-based approach, is of course more of like the charter school approach, or vouchers for private schools, getting the government out of the production process and just more on the funding side. So we're going to, as I'm sure you know, there's an incredibly controversial policy debate between these two approaches, with some people favoring more of the free market approach, some people favoring more of the government-based approach. What we're going to do here is just systematically consider some of the merits and how you can do the best you can within each of these two approaches, and then come back at the end to talk about which might make more sense, right? So I'm going to start by spending a fair bit of time on the government-based solutions in the rest of this lecture, and then some of the next lecture, and then we'll turn to the charter school stuff. Okay, so when we think about improving schools, economists and education researchers often like to think about it in terms of what we call the education production function. So one way you can think about this abstractly is you are trying to produce an output, which is student learning, maybe measured by test scores. And you have a bunch of inputs that you can put into sort of a machine to produce that outcome. What are those inputs? There are things you can control, like how many students do we have in each class? Maybe smaller classes are better because you can do a better job of tailoring your instruction to each student. Or what types of teachers are you hiring? Can you hire more qualified teachers, or teachers who are going to put in more effort to teach students? How important is that input? Or is it about technology? There's a lot of research on whether providing specific technological tools can have significant impacts on how well students learn. So the way I look at it is, it's not, at some level you might say, like, why don't you do all of these things? Like, of course you want to have better teachers, smaller classes, better technology, et cetera. But you have a budget. So let's say you have $1 million. You're trying to improve your school. Where should you put that money? And so what I want to do before showing that data is just ask that question to the class, see what people think. So suppose you have a choice between two things. You're trying to improve the quality of third grade education in your school. Let's say you could pick between a small class, 15 students, and a teacher of average quality. Or you can choose a bigger class and an above average teacher. Which do you think is more important? So basically I'm asking, which is more important, class size or teacher quality? What do you think intuitively? I'll give you a minute. Okay, great. So about 2/3, 1/3 in favor of larger class sizes in order to get better teachers, roughly speaking. Okay, so let's see what the data, this is the type of question I think we can actually answer with modern data with a fair bit of precision. So let's see what we get. Okay, so I'm going to talk about each piece separately. First, what's the causal effect of class size, and then the causal effect of teachers, and then just put those two pieces together to give you the empirical answer to the question I just raised. All right, so when you're thinking about the effects of class size, you can't just compare, like, what's the most obvious thing that you think about doing? Get a bunch of data from a school district. Some students happen to be in smaller classes. Some students happen to be in bigger classes. You might just say, okay, let's just compare their test scores at the end of the year. Did the students who happen to be in smaller classes or in school districts where classes were smaller, did they do better on average? So that is not going to work. It's not going to give you a valid estimate of the causal effect, simply because students in schools with smaller classes will tend to be different in many other ways, right? This is the classic comparability problem that we've talked about several times now in this class. So intuitively, what might happen, kids from smaller classes will generally be from higher income backgrounds. So what types of school districts tend to have smaller classes? School districts with more money, the ones that can hire more teachers. What types of places are those? Those are places, given the property tax finance system, that have more affluent parents. We've already seen many times that kids from more affluent families do better for a variety of reasons. So we are going to, if we just compare kids who happen to be in small classes and large classes, we could end up overstating the effect of class size, because it's going to look like kids in small classes do much better, but it might not actually be because they're in a small class. It might be because of various other things that are correlated with that, okay? So standard problem, we need to figure out a way to get at the causal effect of class size, and so we're going to need to use some sort of experimental or quasi-experimental variation in class size to answer this question. So I'm going to show you results from two studies. The first is experimental, and the second is quasi-experimental. So the experimental study is going to bring us back to the Tennessee data that I showed you at the beginning of the lecture, which is data that was collected as part of a well-known experiment in education called the STAR experiment. So this is the Student-Teacher Achievement Ratio experiment, which was funded by the government with the explicit goal of trying to understand whether class size, that is student-teacher ratios, affect student outcomes. So what they did is, between 1985 and 1989 in Tennessee, they took about 12,000 kids in grades K through 3 at 79 schools, mostly disadvantaged schools in the state of Tennessee, and they randomized students and teachers into classrooms within each of these schools. So just by a coin flip, some students got assigned to classes that were relatively small. They had about 15 students on average, and other students got assigned by chance to classes that were relatively large. They had about 22 students on average, all right? Now, naturally, classes vary not just in terms of class size, which is what I'm going to be focused on here, but also in terms of teachers and peers, and so there's lots of random variation. We'll come back to talking about some of those other dimensions of variation in the next lecture. Okay, so what we're going to do is evaluate the impacts of the STAR experiment in a very simple way by just comparing the average outcomes of kids in small versus large classes. So the beauty of the experiment is we know the kids who were in the small classes here are comparable on average to the kids who were assigned to the large classes because we assign them at random such that their characteristics will be comparable on average. And so the way we're going to do that, those comparisons of means, it's really a very simple thing, but in order to quantify precisely what these impacts are, I'm going to walk you through just a very simple methodology of reporting impacts using regressions of outcomes on an indicator variable for being in a small class. So what is an indicator variable? It's a variable that takes two values, 0 or 1. 0, which kind of means off, the indicator is off, signifies in this context being in a large class. And then 1 means you're in a small class. Okay, so 1 is an indicator for being in a small class. So I'm going to talk you through how you read these results in the context of a regression table, which those of you who've taken an econometrics class will have seen. Those of you who haven't, just walk you through what that looks like in a couple of minutes. This is a standard thing that you'll see in lots of papers. So on the top, we see the dependent variable in the regression, that is the outcome variable in the regression that we're examining. In the first column, it's the test score. And then the second and third columns, we match this data to the tax data. And so we're able to look at college attendance rates. We're able to look at earnings. Okay, so those are the three sets of outcomes we're going to be focused on. Let's concentrate on the first column. The first number you see there reflects the impact of being in a small class. So formally, that is the coefficient when you regress test scores on that indicator for being in a small class. The coefficient there is 4.81. So what that is telling you is that the estimated impact of being in a small kindergarten class, 15 students, instead of a large kindergarten class, 22 students, is 4.81 percentiles on average. That is, the kids randomly assigned to the small class are doing quite a bit better, about 5 percentiles point better on average than the kids in the large class. Okay, so that's the first number you see there. The second number you see here in parentheses is the standard error. So the standard error captures your uncertainty about that estimate. So that 4.81 number, we don't know for sure that if I were to repeat this experiment thousands of times, that I'm always going to get 4.81, right? It'd be kind of surprising. Part of the variation is driven by just random chance that the kids in small classes, you happen to have a few extra kids who scored really high on the test. Kids in the large class happen to have a bad day when they were taking the test or whatever. So there's going to be some just random variation just due to chance. And so the standard error is a way of quantifying how much uncertainty there is in the estimate due to that sort of random chance. And so in particular, using the standard error, which sometimes colloquially in the media people will call it the margin of error in an estimate, like if you're looking at a poll, for example, what you can do with that is construct what we call the 95% confidence interval, which is basically plus or minus 1.96 times the standard error. Why 1.96? It turns out with a normal distribution, you can show that the standard error translates to a 95% confidence interval with this 1.96 factor. You don't need to worry about that at the moment if that's not familiar to you, but basically that's the calculation we're doing. And that gives you, if you take 4.81 plus or minus 1.96 times the standard error 1.05, that gives you a range for the 95% confidence interval of 2.71 to 6.91 percentiles. So the way to think about that intuitively is you don't know for sure the estimate is 4.81, but you have a high degree of confidence in some sense that it's between 2.71 and 6.91. That's kind of a plausible range that the true effect could lie in. And so, roughly speaking, an intuitive way that you could think about it is suppose hypothetically we were to repeat the Tennessee star experiment 100 times. 95 of those 100 times, we would expect the estimates to lie between 2.71 and 6.91. They're not always going to be 4.81, but we can be pretty confident that they're not going to be like 0, and they're also not going to be plus 10. So this gives you a sense of, we're decently confident that there's something like a 3 to 7 percentile point effect of being in a small class. It's a pretty significant effect. It's not huge, and it's also not 0. Okay, then the final piece of information that's useful here is the average value of the outcome, just to give you a benchmark to compare it to. So the average test score in this sample is the 48.6th percentile, and you're going up 4.8 percentiles relative to that average. So that gives you kind of a sense of the scale at which you're affecting things. So now jumping to these other columns, we see that there's some significant impact on college attendance rates. Your probability of going to college goes up by about 2 percentage points if you were assigned to a small kindergarten class. You might ask, is that a big effect? Is that a small effect? The way I think about it is, this is just being assigned to a small kindergarten class just like once, for 1 year of your education, basically, right? And so if you think about now being in a small class, not just in kindergarten, but in first grade, second grade, third grade, all the way through high school, and if you make the assumption that these impacts are going to be kind of similar, and I'll show you some evidence supporting that, then that could add up to a pretty significant effect, 2 percentage points higher probability of going to college for each year of exposure to a small class is going to give you like a 20 percentage point impact from reducing class size throughout school. So it actually adds up to a pretty sizable thing, even if that 1-2 percentage point effect doesn't look so big in and of itself. The third column, you look at earnings. So this illustrates, I think, an important statistical point. So you see the estimate here is actually minus $4. Okay, so it's basically zero, right? So if you were to just read that at face value, the conclusion you would draw from that is it looks like putting kids in smaller classes doesn't actually improve their earnings. But that is not the right conclusion, I think, to be drawing from this analysis. Again, you have to look at the amount of uncertainty you have in that estimate. And you see the standard error there is about $320, right? So what that means, if you do plus or minus 1.96 times 327, it means that the 95% confidence interval for the earnings impact is very large. It could be anywhere from minus $640 to plus $637, all right, of annual income per year relative to an average of $15,000. So in particular, the earnings impact, and sorry, that should say could be as large as 637, 4% increase, right? It could be that putting kids in a smaller class for just 1 year increases their earnings by as much as 4%. Now imagine again the exercise I did before, you put kids in a smaller class for 10 years, that could yield a 40% increase in earnings. So what this is really telling you is you don't have enough data to say for sure one way or the other whether small classes matter or not for earnings. The estimate is zero, but it could be as big as a 40% gain if you were to put kids in a small class for 10 years in a row. It's just not a big enough sample to figure that out. And I emphasize that result here because I think there's a tremendous amount of misinterpretation, especially in public discussions about results like this that are statistically insignificant but are very imprecise. The right way you should read those types of results is you really can't conclude from the study. Whereas often, a journalist might write about this as saying, the study found no significant impacts on earnings, which seems to suggest that there was no impact on earnings, but really what that means is there's no statistically significant impact. You didn't have enough data to really figure it out, okay? So it's very important to look not just at the estimates you're getting, but also at the standard errors and at the confidence intervals. How much uncertainty do you face, okay? So the substantive lesson from the STAR experiment is that class size seems to matter. And in particular, it seems to increase test scores. There's some evidence that it increases college attendance rates, but it's just too small to estimate the impacts of class size on earnings precisely. You just don't know. And so that illustrates a trade-off that I've talked about in earlier lectures, where with a pure experiment, it's very nice because you don't have to make any additional assumptions. You have this very clean estimate of a causal effect. The problem is, even with 12,000 kids, it's not a big enough sample to really be able to get at some of the effects you care about. And so because of that, we're now going to turn to the second study by Fredriksson et al. That uses administrative data from Sweden to obtain much more precise estimates. Here, there's no experiment, but they're going to use a quasi-experimental method, which we talked about in the last lecture, regression discontinuity, which I think is going to give you as compelling estimates that are going to be much more precise. Okay, so how does this work? And this is going to be very closely related to those of you who've started working on the second empirical project. This is essentially the same sort of design. Sweden imposes a maximum class size of 25 students. Okay, so what that does is it creates an interesting discontinuity. Suppose in your school in some town in Sweden, you happen to have 26 students in a given grade. By law, you cannot have a class that has more than 25 students. So what you have to do is split your grade into 2 classes of, say, 13 students each in order to comply with the law. So, but in contrast, if you happen to have 25 students, you could have 1 class of 25 students. So what's going to happen is when you cross this threshold of going from 24 to 25 to 26 students, the average size of the class that students are in is going to suddenly fall every time you cross an integer multiple of 25, right? And so that creates a very nice source of variation from the statistician's perspective, to identify causal effects, because the schools that happen to have 26 students in a given grade are likely to be very similar to the schools that happen to have 25 students just by chance in a grade, right? And so you can identify the causal effects of class size by comparing the outcomes of students in schools with 26 students versus 25 students in a given grade. So to show you visually how that works, I'm going to show you a set of graphs that look very similar to the ones from the Seth Zimmerman Florida International University paper that we talked about. It's the same regression discontinuity methodology. Okay, so what we're plotting here is, first, the vertical line is the cutoff for maximum class size. So think of this, to make it concrete, as being 25 students. It could also be like if you have a school of 50 students, going from 50 to 51 is going to put you past that threshold, right? And you're going to have to add a third class. So we're going to call 0 the point at which you cross that threshold. And then what we're plotting is, on the vertical axis, the average class size that students are actually in. This is for 4th to 6th graders, versus the enrollment relative to the threshold in 4th grade, okay? The total enrollment in that grade. Like, did you have 25 kids, 28 kids, et cetera? And so what you can see is exactly what I was describing would happen intuitively. Right when you cross that threshold, when you have 26 students instead of 25, the average class size falls. And in particular, the class size falls by, on average, about 5 students when you cross the threshold. So if you happen to be in a school with, say, 76 students instead of 75, you average over all the different scenarios, you end up in a class that has 5 fewer students on average. So there's basically a treatment for the kids who happen to be just on the right relative to the kids who happen to be in schools just on the left, of a 5-student reduction in class size. Now, the underlying assumption that we're going to make is that there's no other difference for the students who happen to be just to the right relative to just to the left. And so then they do a bunch of stuff in the paper to show that that appears to be the case. If you look at the characteristics of students, their gender, their parental background, et cetera, they look pretty similar on the left and the right, as you'd expect intuitively. So this seems like a pretty good quasi-experiment. So what you can then do is start to look at outcomes. So this is now plotting test scores versus the same x-axis variable. And so you can see that as you are in larger and larger classes, there's a declining relationship between test scores and class size. But the thing that's of interest here is, notice there's a very clear jump right when you cross the cutoff. Right when you get to the situation where average class size in your school is 5 students smaller, your test scores go up by, something like, this is in standard deviation units, it's about 0.2 standard deviations, okay? And so we'll talk more about the units of that in a second, but basically there's a significant jump in test scores that's going to be roughly in the ballpark of what we found, that 5 percentile point gap that we found in the Tennessee Star experiment. Now, that finding basically replicates what we saw in the experimental data, right? So it's like another proof that class size really seems to affect test scores. But what's cool about this is that you can now do this with earnings, and you actually have enough data, because you're using all of the Swedish data to do this. You actually have enough data to see that there's a fairly clear jump in earnings as well to the right of the cutoff relative to the left of the cutoff, right? And in particular, the units here, this is in log income. So the way you can interpret that is earnings jump by 0.04 log points at that threshold. And what that means in simpler terms is that earnings jump by about 4% at the point of the cutoff, okay? So what it's basically saying is, reducing class size by 5 students, this estimate suggests, would cause about a 4% increase in earnings. Notice that that is near the top of the confidence interval that we found in the Tennessee Star data, where the estimate was 0, but the confidence interval was kind of going up to a 4% increase in earnings. And that's basically what they end up finding with this much larger data set. So what you end up finding with this quasi-experimental methodology is totally consistent with what you find with the Tennessee Star experiment and really seems to suggest that class size has important impacts not just on student achievement as measured by test scores, but on later outcomes as well, all right? So to summarize, what do we learn from that exercise? So I think the key conclusion is that reducing class sizes in primary school by hiring more teachers can have quite large returns. In particular, you can quantify it as follows. So if you think about the present value of lifetime earnings of a child growing up in a family at the 25th percentile of the income distribution, that's about $500,000 on average. So what do I mean by that? If you take a kid growing up in a family at the 25th percentile in the US and add up their total earnings over their entire life, on average, it's going to put you somewhere around $1.3 million, something like that. On average, that's how much people will end up earning over their lifetimes for kids born to low-income families. We then, recognizing that money earned 50 years from now is worth less than money earned today, because money earned today can be invested and grown, basically. That's one way to think about it. What economists like to use is a concept called present value, basically putting less weight on money earned in the future relative to money earned today. And so if you do that and add that all up, the cash equivalent in terms of average earnings today for a child born to a low-income family is about $500,000, roughly speaking, okay? So now we've seen from the Fredrickson et al. Study that if I put you in a smaller class, a class with five fewer students, on average, students earn about 4% more. So what's 4% of 500,000? It's about $20,000, okay? And so, just scaling it by that $500,000 number, we see using their estimate that if we put a single kid in a smaller class, that's going to increase the present value of their lifetime earnings by about $20,000, okay? So concretely, what does that mean? If I take a class of 30 students and divide that class into two, that would increase the total earnings of students in those classes by more than about 600,000, adding up over all of those students. Now, that would require hiring another teacher, obviously, in order to divide the class into two. So, but presumably the costs of hiring one more teacher and the additional space you need for an additional class are likely to be well below 600,000. So what this estimate suggests is that reducing class size could well pay off quite significantly. Okay, let me stop to take some questions up here first.
The first test in Tennessee,
yeah.
you said was kind of the 1-year effect was like 2% or 4%. And then is the Fredrickson also the 1-year effect of smaller class size? Assuming if they're studying school districts,
yeah.
having 26 kids, they're going to have that same like first grade and 10th grade. So
yeah. It's a very good question. I think you should interpret it as basically the effect of a 1-year difference in class size. And the reason is you're right that if you exactly persisted with 26 students year after year, you'd be to the right of the cutoff every single year. In practice, there's enough fluctuation. One kid moves out, one kid moves in. It's going to bounce around a little bit. And so effectively, a school that was treated 1 year is going to move into the control the other year. So, and I think they make efforts to basically construct an estimate that gives you a 1-year impact. But I mean, good intuition that would matter, yeah. Let me go to the back first and then, yeah.
When all the classes are, like assuming you would split all the classes into groups of 15 and one group of 30, the 40% higher earnings, assuming those are 40% better paying jobs, wouldn't they crowd each other out? Like there's not
yeah.
double amount of higher.
Good question. So that gets to a deeper issue with all of this education stuff, where all of the studies we're able to do are what we call partial equilibrium, meaning we're changing one kid's environment and looking at the impacts on that kid's earnings, holding fixed everything else in the economy. The question you're asking is what economists would call general equilibrium. Does the equilibrium itself change if you put everybody in smaller classes, right? And so take two extreme views. One view is there are only a certain number of good jobs in the US, or like one way to think about it is, suppose you're thinking about admissions to Harvard. There are only 1,600 seats. You put everybody in small classes, You might see that for a given kid, if they're in a smaller class, they're more likely to get into Harvard. But of course, that doesn't mean the total number of kids who go to Harvard, if we put everybody in small classes, is going to change, right? So one extreme view is in equilibrium. There's, in that example, 100% crowd out effect. If you do better, I kind of do worse. It's like a zero-sum game. A different view of the world is that it's about human capital building, and you're smarter, more productive, you invent new things, you figure out how to do things better. That just allows you to earn more and doesn't kind of take away my slice of the pie. You can't tell from these studies which of the two it is. I think it's kind of a separate research question. As you increase education on scale, are there significant crowd out effects? My best sense from people who've studied things like compulsory education changes, where you have a whole, like millions of people getting more education because the minimum dropout age changed, is that those crowd out effects are not that large, actually. So most of it is about making people more productive rather than competing for the slice of the pie in a zero-sum game. But you're absolutely right that just from this evidence, you wouldn't necessarily be able to tell. Yeah?
So earlier when you were talking about test score outcomes and the sort of exacerbation that low-income kids face when they're in testing,
Yep.
how do you, like, do we know what the effect of moving opportunity is on these kids if they're being put into better neighborhoods with better schools, but still come from low-income backgrounds?
Yeah, I mean, we know from the earlier work that I've talked about in this class, not specifically in the context of schools, but we know that moving to opportunity can have quite significant benefits for kids, right? Not just in terms of test scores, but we saw low-income kids can have dramatically better outcomes if they move to better areas. But importantly, so I guess what you're asking is how is that consistent with this sort of evidence where you see low-income kids in those places not necessarily doing as well as the higher-income peers? So I think there are two different things going on. So first, in terms of levels, we are not saying from that analysis that low-income kids don't benefit from being in a more affluent school district. They do better. It's just that the high-income kids do even better, so the gap gets worse. So you should not draw the conclusion from what I was showing you with the Reardon data that it's not a good idea to have low-income kids in better resource schools. It is. It's just that it doesn't completely close the achievement gap. The second thing is, when we were looking at the moving to opportunity stuff and the differences in outcomes across places, it wasn't just about average outcomes, like average level of resources. Lots of other things matter too in terms of defining a good neighborhood and a good school. So there might be ways to help people move to opportunity, which is not just on the dimension of moving to the right side of that chart. And that way you can achieve even bigger gains. Okay. Yeah. Awesome. Yeah. It's not where a kid goes to school, right? You're going to the same school, it's just the size of the class you're in. Yeah, so Lamar Alexander at that time, was really interested in this stuff, and then there were a bunch of people who felt this was an important question to study. The legal basis for this being something that you can do, where you randomize class size, I actually don't know exactly how that was justified. I agree with you that it's quite surprising that you had an experiment like this. That's why it's so rare to have experiments like that. But in this case, it was feasible. It'd be interesting to dig into more, exactly how it happened. Okay, so what we're going to do next time is talk about teacher quality in the way that we've talked about class size today. Thank you.